Question number 10. We have a continuous random variable x whose density function fx of x is given as 1 upon 2 sigma e to the power minus of mod of x by sigma. Okay. Here x is lying between minus infinity to infinity. We are taking 10 samples from x. So let's denote this as x1, x2 up to x10. This is 4, minus 2, 2, 1, minus 4, 5, minus 1, 2, 3 and 6. Okay. So this particular sample has been taken from the random variable x. Now we have to find the maximum likelihood estimate of the parameter sigma. So so how do we find the maximum likelihood estimate of a parameter? So the first step is we find the likelihood function. So we have Lx1, x2 up to xn. If we have a sample of size n, it is written as product of fx of xi with the parameter theta. If let's say the parameter is theta, but in this case the parameter is sigma. So let's write it as sigma I varying from 1 to n. Now the sample size is 10 and fx of x is given as 1 upon 2 sigma e to the power minus x by sigma. This likelihood function becomes product of I varying from 1 to 10, 1 upon 2 sigma to the 1 upon 2 sigma e to the power minus of mod of xi by sigma. Okay. This 1 upon 2 sigma we can take it out. So 1 upon 2 sigma to the power 10 e to the power minus of mod of x1 by sigma e to the power minus mod of x2 by sigma up to e to the power minus of mod xn by sigma. Okay. And this can be written as 1 upon 2 sigma to the power 10 e to the power minus 1 by sigma sum over mod of xi I varying from 1 to 10. This is the sample that we had taken from x. Once you take the mod of the sample, this becomes, so sum of mod of xi I varying from 1 to 10, this becomes 30. So our likelihood function x1 up to x10, this becomes 1 upon 2 sigma to the power 10 e to the power minus of 30 by sigma. Okay. Once we got the likelihood function, then we go for the log likelihood function. So let's find the log likelihood. So log likelihood function x1 up to xn equal 10 times log 1 upon 2 sigma minus 30 by sigma, right? And this can be written as minus 10 log 2 sigma minus 30 by sigma. Once we found the log likelihood function, we will differentiate this log likelihood function with respect to the parameter sigma. So the third step is you differentiate the log likelihood function. So with respect to sigma, so d upon d sigma minus 10 log 2 sigma minus 30 by sigma. This is equal to minus 10 upon 2 sigma times 2 plus 30 upon sigma square. Now we equate this to equal to 0 to find the value of sigma that maximizes the likelihood function. Okay. So once we equate this equal to 0, so this is nothing but minus 10 by sigma plus 30 by sigma square equal to 0, and it becomes 30 by sigma square equal 10 by sigma, and this is 10 sigma square minus 30 sigma equal to 0, and sigma 10 minus, let's take it 10 sigma, so sigma minus 3 equal to 0. So we get sigma to be equal to 0 and sigma to be equal to 3. the maximum likelihood estimate of sigma. So sigma hat ml is going to be